In an earlier Did You Get It question, we found the mean of the land areas of the 15 largest states, listed here in thousands of square miles. This time we're asked to find the median. And the way you should think of the median is when you have a data set listed out in order, the median is going to be the guy that lives right in the middle, has the same number of values above and below. Fortunately, in this particular question, the data values are provided for us in order. So the first step is usually to take all the data values and write them in order. We don't have to do that here because they're already in order. Yay for us. Better still, notice that if you look at the top line here and compare to the bottom line, you can see that if you throw away 104, the top and bottom have the same number of values. There's 7, then 104, then 7 more, which means 104 has 7 values above and 7 values below. That means 104 is the median of this list. Now we just need to interpret and write an intelligent answer. 104 doesn't make sense because we're trying to find the median land area for the 15 largest states, and they're listed in thousands of square miles. Since we find that 104 is the median, that means that the median area for those 15 largest states is 104,000 square miles. Now, in an earlier video, we saw that the mean, so let me go ahead and label that as median. We saw that the mean was actually 151,133 square miles, and that's a whole lot of difference. Trying to come up with an explanation of the discrepancy in no words or less, there's an explanation of the discrepancy. That's Alaska for what it's worth. And it's so much bigger than all the other states that it has a big effect on the mean. But it doesn't affect the median, because think about it this way. If that number were 270, it wouldn't affect the median at all. The median simply wouldn't care because 104 would still be in the middle of the spread here, the distribution, and that would still be the median. But if that were 270 instead of 665, that would change the mean by quite a lot because we'd be bringing down the sum of all the areas so that when we divide by 15, we'll get a smaller result. And that's a pretty good explanation, I think, I hope, of why the mean can be a lot more affected by one or two unusually small or large values than the median. The size of those one or two values doesn't really make any difference to the median, just where they live in the list, but the size of those values most definitely does have an effect on the mean.